Hi everyone, in this lesson we are going to talk about why atoms form bonds and the three different types of bonds. So let's go ahead and get started. So why do elements form bonds? Obviously we have a ton of compounds in our daily life that we use to charge our phones, to cook with. All of these compounds are made up from individual elements, so somehow they have to form these different types of bonds. Some important vocab and definitions to keep in mind during this unit. Remember that a chemical bond is simply the force that holds atoms together in a chemical compound. Something has to hold them together, and that's your chemical bond. I will often refer to a binary compound. A binary compound is a chemical compound that contains two different elements. So it could be NaCl, H2O, CO2, as long as it has two or more different elements. Valence electron is the outermost electron in an atom. It's the lowest located in the highest energy level, furthest from the nucleus. Your ionization energy is the energy needed to remove an electron from an atom. So ionization energy you're taking away. And electron affinity is how likely an atom is to gain an electron. So electron affinity wants to gain electrons if enough energy is released when an electron is added. And then lastly, we have electronegativity. How attractive is an atom to electrons, and how willing is the atom to share those electrons? Some elements are much more willing to share their electrons than others. Some want nothing to do with it, and some are very into sharing. So let's go ahead and continue on. One thing to remember is the Octet Rule. 8 is great is our motto. It is based on the idea that atoms always want 8 valence electrons. A great tool for predicting what bonds will form, but it does not necessarily explain the reason why. So like we said, they want to get to that 8, so they're going to gain or lose electrons in order to have 8 valence electrons, but it doesn't necessarily say why this one's bonding to this. Sometimes elements bond for no reason at all. Atoms do want to evenly spread out their electrons if they can, so when they are drawn, they're evenly spread out throughout the entire atom. They're not all bunched in one corner. So why do elements form bonds? They're going to form bonds to lower their overall energy. They want to become more stable. Everyone wants to become more stable. But the question they have to ask themselves is it worth it to take in the electron? The atom taking the electron must be able to pay for it in an energy. So the ionization energy of the electron being removed must be less than the electron affinity, which is being released or paid for. So it's always a give and take. You don't get anything for free. So why bother making these bonds if it costs energy? All the atoms want to have a full outer shell, just like your noble gases. So if we look here, we can see that neon, the highest energy level is 2, and it has 8 valence electrons. 2 plus 6 is 8. Argon, the highest energy level is 3. 2 plus 6 is 8. It too has 8 valence electrons. So neon and argon are both very happy. However, if we look at sodium, sodium's highest energy level is 3. There is only 1 electron there, so it only has 1 valence electron. It is not happy. It is not stable. It wants to have that 8. So which electrons are involved in bonding and why? These are your valence electrons because they require the least amount of energy to remove or share them. The attractive pull is much weaker because it's further from the nucleus. The farther you move from the nucleus, the weaker the pull. There are 3 types of bonds that all of these elements will form, okay? And we're going to talk about each one of those. So what happens during a chemical reaction or when 2 elements bond? There is a chemical reaction, there's a change in the electrons. It's no longer going to have the same setup, no longer going to have the same arrangement. They're either going to transfer or share electrons in order to make bonds. Nothing is free. So there are 3 types of bonds. The first is an ionic bond in which your electrons are transferred. This typically occurs between a metal and a nonmetal. One of them is going to give up electrons, the other one is going to take electrons. In a covalent bond, your electrons are shared. So they are shared evenly. It's kind of like if you split a dinner with somebody else. You're sharing it equally. You cut a sandwich in half. A covalent bond typically occurs between a nonmetal and a nonmetal. They share evenly. It's not mine or yours. They're shared equally. The third type of bond is a metallic bond. And in a metallic bond, your electrons are free flowing, and it is between a metal and a metal. In this lesson, we're going to primarily focus on ionic and covalent bonds. So in an ionic bond, we have a transfer of electrons. In an ionic bond, we said we have a metal and a nonmetal. Metals always have that low ionization energy because they want to get rid of their electrons. Metals are always willing to give them up. Nonmetals are very greedy. They want to gain. They have a high electron affinity. So therefore, we always transfer electrons from a metal to a nonmetal, making metals are cations and anions, and nonmetals are anions. Nonmetals will always be our anions because they are always gaining, so they're always gaining negativity. Metals will continue to be cations and be positive because they are losing their electrons. So let's do an example together. Sodium has 11 electrons. We can see the electron configuration right here. It only has one valence electron. The highest energy level is 3. It has one valence electron. It is going to lose this one valence electron, so now it becomes 1s2, 2s2, 2p6. This is a full outer electron shell because the highest energy level is 2, and 2 plus 6 is 8. So if sodium loses one electron, chlorine can gain one electron. Chlorine has 17 electrons. If we look at the highest energy level, it is 3. 2 plus 5 is 7. It only needs one more in order to be happy. So when it takes that one from sodium, it now is 3p6, and it now has a filled energy level. It is now happy. The two happy ions now attract each other electrically. The resulting attraction is in an ionic bond, so a metal and a nonmetal. A bond between ions, the metal always donates the electrons, and the nonmetal is always going to accept. So here we can see sodium giving up the one electron to chlorine, and now chlorine has 8 in its outer shell. Some properties of an ionic bond are they're typically solids with very high melting point, so it needs a lot of heat to melt. They are soluble in water, which means they can dissolve. The molten compounds are going to conduct electricity well because they contain mobile or charged particles like an ion. An aqueous solution is going to conduct electricity well for the same reason. So an aqueous solution is just simply a mixture of it, but everything is dissolved. Okay? Our next type of bond we're going to talk about is a covalent bond. In a covalent bond, there are sharing electrons, and they're typically nonpolar covalent. So like we said before, they're typically between a nonmetal and a nonmetal. So when you share electrons, it's going to trick the other one into thinking it has 8 electrons, even though they are sharing. Okay? They each donate what they can. So here, we know that carbon has 4 valence electrons, 1, 2, 3, 4, and 1, 2, 3, 4. If they each share, they now have 8, which makes them happy because they're sharing. Another example is fluorine. We have 2 fluorine atoms. Fluorine we know has 7 valence electrons. So fluorine is going to each share 1. So when they overlap and they share, each fluorine is now happy. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So each fluorine is now happy. Another example would be CH4. We have carbon in the middle, and we have 4 fluorines that surround it. If we look here in the middle, or if we look over here, we see that carbon is represented by orange electrons. Fluorine has blue ones. As we overlap, carbon is going to share 1 with each fluorine, and each fluorine will share 1 with carbon. So now carbon is happy, it has 8, and each fluorine is also happy, it now has 8. Some properties of a covalent bond include they do not conduct electricity. So covalent bonds, there are no metals in them, so there's no electricity. They have very low melting points. They're going to melt very easily. And they are typically not soluble in water, so they will not dissolve. Our last one is a metallic bond, which is between a metal and a metal. The electrons are able to flow freely through a metal in a sea of electrons. Okay, so this is your free-flowing electrons. It's a sea of electrons. We can see the electrons flowing through here. They just kind of work their way through. Some properties of metals or metallic bonds include they are solid at room temperatures. This is your gold, your silver, your zinc. The only exception for this rule is mercury. It is a liquid. It used to be in the thermometers, but it no longer is because it is poisonous. Metallic bonds do conduct electricity. They are malleable and ductile, and they have a very wide range of melting points. So these metallic bonds typically occur in that middle of the periodic table, those transition metals, which is why they have such a wide range of melting points, because there's such a wide range of elements. Now, some properties of the compounds often have very different properties than the individual elements. For example, sodium is a very explosive metal when it's put into water. Chlorine is a very poisonous gas. However, when you combine sodium and chlorine, the chemical properties are now different, and it's something that you put on your French fries. Okay, so why do these properties of compounds, molecules, why are they so different? Because the chemical properties are due to the electron configuration of the valence electron. During bonding, the configuration changes. So the configuration changes. It could be gaining an outer shell or completing it. It might be losing an outer shell like sodium did here. Sodium only had one valence electron. So when it lost its last electron, it now only has 2 rings. It's a very different compound when it gains or loses electrons. Okay? What questions do you have for me? I hope you were able to learn a little bit more about the ionic, the covalent, and the metallic compounds, and keep those different properties in mind as you go through today's lesson and future lessons.